Our first speaker will be myself. I'll be talking about data on different computers and what's the idea behind it and why do I speak about it. I had contact with some consultants in some other function, and they were trying to sell their software system to a customer with, you should put all your data in one database, because then you have a single source of truth. There are multiple tools to make it consistent, even if multiple is written totally wrong on my sheets. You can do queries and analysis of the data across all the areas of your business, and it's the smallest possible complexity. So if it's so great to have everything in one database, why should you even do something with databases on multiple computers? Some of my experiences are relevant to this. That's something around 1994. I was a CIO at a sales company. I managed the development of a customer relationship management, and I migrated from FoxPro to PostgreSQL and PHP. Sorry for PHP, but I needed the money. So then I owned my own company since 1999. I developed various tools across various databases, especially the big red one, Redwood. And I hit the jackpot with a very funny spelling by doing a browser-based application to do checklists, and it was just at the right time. So it helped me, and it helped me to visit the PostgreSQL conferences, that time in France, in Paris, and getting in contact with Second Quadrant. I was invited to become a partner in running the German affiliation of Second Quadrant. So the objective of this talk, I want to give some overview for the reasons why it may be necessary or even be useful to have data on multiple machines. I will give an overview of some of the techniques with their possible area of usage, their contraindications, and the side effects of those techniques. It won't be an in-depth thing of those things. And I want to give you some nudges to think about the questions to ask yourself when you decide, should I put my data on different computers? Should I not do it? And if I do it, which way shall I do it? The methodology to do this, I will build up a sample story of a Towel Sales Europe company founded in Hamburg, Germany. And the software is Towel Sales Management. In its first version, it's a multi-user system, but it has just one central database. Everything works fine, offers, delivery notes, bills, even the business reports works fine. It's a very small company selling some 100,000 of towels every year. Everything is good. One day, that's like the comic Bang, the server went up in flames. Nothing works anymore. The request is, the server is destroyed. If that happens again, we want our business to continue. We want to sell towels, 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 even if the server is destroyed. So how to do it? The first bad idea, and that's one thing a lot of people ask us to do, is to have two computers and one hard drive. Nobody has hard drives anymore. It's storage area, it's networks or whatever. And to do a switch over with one hard drive or whatever you call hard drive these days and two computers. Why is it still a stupid idea? There's a single point of failure, still your hard drive, your storage, which can go up in flames or be bad. It's a good idea because you have to buy just one hard drive or whatever you call it today. And those clients asking us to do a setup with this, we have a saying, if you use PostgreSQL and you do that switch over, it's not a question if your data will get corrupted, it's just a question when it will become corrupted. The challenge is if you have two PostgreSQL processes accessing the same data at the same time, it will get corrupted. So, bad idea, don't do it. Low-level data duplication is a way to replicate the data on operating system, virtualization, or storage level. Some operating system vendors, virtualization or storage vendors claim that they are able to transactionally consistent duplicate the blocks written to the file system. XFS claims something around, ZFS claims ZFS claims something around that. And those solutions are usually quite proprietary. That is operating system proprietary, virtualization or storage thing. So it's a very special skill set, and it's usually tied to one vendor. So if you trust them and you want to stay with them, maybe. I'm a database guy, I'm an open source guy, so I skip over that way of solution and recommend the duplication and replication on the database level. Replication, we have currently two major ones. The one is based on triggers, and the other is based on WAL files. WAL files can be shipped or they can be streamed. Same basic technology, different implementations. Just an overview, pros and cons. Trigger-based replication. First one that was developed was Sloney by Jan Wiek many years ago with a very, very old PostgreSQL thing. He made it work, which was quite genius. The guys from Skype decided it's too complicated to manage anyway. How is it working? We have the databases on the master node. That's a table. Every time you do some data manipulation on one of those tables, a log table is written. As in, I insert into special table, then that command insert into that table is written to a log or queuing table by that trigger. And a replication agent is reading that queue table and applying the same commands here. The guys at Sloney and Londiste made some really magic, so you don't have to write insert, but it's just an I, and they found a way to shorten some letters to only 6 bits and something. So it's really magic, really great thing. Anyway, the data is written 4 times in a trigger-based thing. If you write to a normal PostgreSQL table, locked standard PostgreSQL table, the data is roughly written 2 times. So if you write 100 bytes into a PostgreSQL table, roughly 200 bytes are written to the disk subsystem. If you do a trigger-based replication, that happens 2 times. You write in the write-ahead file from your main table, you write in your main table, you write in the write-ahead file from your queuing table, and you write in your queuing table. So roughly for every 100 bytes, there are 400 bytes written to the hard drive. That is a lot. If you have that trigger-based thing, changes in the schema, data manipulation language is simply a pain to get it right to the other system, and a lot of support calls result from it doesn't go easy, it's painful. On the master, we have the cost of the trigger, because after writing or before writing, you have to fire that trigger who has to write in that queue table, and only after that trigger has finished, the control will be returned to the calling process. That's the cost. And the slave node has the cost of parsing that SQL, which is delivered to him. The good thing is, it's enabled between various versions of PostgreSQL. So you can use this method of Londiste or Sloney to do an online upgrade by replicating from 9.0 to 9.3. Even replication by trigger-based solution from other databases to PostgreSQL is possible. Second Quadrant did a project with Teradata where we replicated Oracle to PostgreSQL on this thing. And we just used documented things like triggers on the Oracle, put it in a queue table, and applied it to PostgreSQL. It sounds more simple than it was. Replication of simple tables is single tables is possible, so you don't have to replicate the whole system, just single tables is possible. Now, the other option is write-ahead log-based replication, which was developed roughly in 1340 in Genoa here in Italy for the bookkeeping. Bookkeeping was done by writing everything you want to change in your main books in a journal. The journal we call in PostgreSQL wall records write-ahead log. In bookkeeping, it's called journal. And then the main bookkeeper is writing everything in the main book, which we call table files. So a very old tradition, it works. It's been done with a lot of locked file system like ext4, XFS, and PostgreSQL has done it before. We are hip. That wall-based duplication has specific features as it's done in PostgreSQL. You always get the whole cluster. That is not a single table, not a single database, but the whole PostgreSQL cluster is replicated to the other server. Changes of schema, DML, is painless if you use wall-based replication, maybe log shipping or streaming replication, because it's just the changes that are written to the write-ahead log anyway are shipped to the other machine and applied. The load on the master server is very small, the additional load. The configuration parameter in PostgreSQL conf is wall level. Usually it's minimal. If you want to archive, it's archive, and if you have the streaming replication with a query server, it's hot standby. But we are talking about less than 10% more bytes that are written, and the processing overhead to writing those is negligible. So we have no overhead for parsing on the slave side, because he does just that applying of wall records he would do anyway if he created them himself. And the technology that is used to apply those wall records is a very old and proven technology, because PostgreSQL is recycling its crash recovery logic. So the slave is put in a mode where he thinks he is always recovering from a database crash. And if you query select PG is in recovery, a slave will return true. We keep him in recovery and we stream on the WAR files from the master, and he applies it to the databases, so we have no overhead for parsing. On the other hand, while in recovery, the slave is on read-only mode. That may be positive or negative, it's just the effect. If we take those write-ahead log informations and push them somewhere into the cloud or into another data center or on tape or on punch cards and store them out of the usual, in German it's Brandabschnitt or complex, which are terms from insurance industry, somewhere else. If a meteor strikes your data center, you have put it somewhere else. You can do point-in-time recovery with those files or disaster recovery if your data center is gone. Those duplications, if you do the trigger-based or the wall thing, allows you to do maintenance and upgrades of your database. The trigger-based across versions, the streaming-based within minor versions. So the usual thing is you have 9.4.3 and you want to go to 9.4.4. So you take your slave, upgrade it to 9.4.4, do a switch over so he becomes a master, and then upgrade the master to 9.4.4, and you have your cluster upgraded in minor version without any downtime. It's high available. If one of those server gets, it's still there. You have a duplication of data storage and server, but it's more complex than a single server. People always ask, why do we have to pay support fees for the slave also? Because the number of things that can go wrong if you have two computers and they are streaming with each other is higher than if you have just one computer. So you pay for one risk, but it's more complex. Sorry, no free lunch. So we have something in the world like rain and heat. The towel sales skyrocket, and business is asking for more business reports. And all those select all customers who bought more than 20 towels in colors of the European Union, but don't include those who bought Icelandic colors. put a lot of load on the database. So what can we do? The first, we build a read-only reporting server. I showed you the trigger and the streaming replication thing. Both are valid options to put it onto another server. So we have our operational server where we do the sales of the towels, and we have our reporting server as a hot standby with streaming replication or Triggerbased, and we do all the business reports there. With Trigger, the decoupling is a little bit better than with streaming replication. The feedback is not that big. Still, long-running transactions in those replication in this tightly coupled systems are a hassle. With streaming replication, the coupling between the slave and the master is even worse or tighter. It's not worse, it's tighter. Tight might be good in some instances. Why is that a challenge? PostgreSQL realizes its rollback and commit method with multi-version concurrency. That is, if you do an update in PostgreSQL, the record is not changed, but another record is added to the table, and the validity of the old record is set to end with the current transaction. So if I'm at transaction 75, and I do an update to a record, that record is marked, this record is only valid to transaction 75. So if you have on your master those updates and they declare 1 million records for invalid because you updated them, but the slave is still doing a long-running query on those updates, like accumulating all the European stocks with Britain still in them. It takes some time to accumulate that. Maybe the master would be already good enough to get rid of those old rows, to vacuum them, to make them available again. Then the slave will send with hot standby feedback, hey, I still need those records. Now we have two options. We can tell the slave, sorry, you're too slow, and cancel his query. Then we are allowed to do the vacuum on the main server and reclaim the storage. Or we say to the master, hey, wait for that slow guy. Then we can't make the space available in the master. So we get some bloat for the time being. That's no problem if you have 10 transactions per second. That becomes funny if you have 1,000 or 10,000 or even more our mass updates. Method 2, extract, transform, load into databases for analytics or into analytical tools like Excel, Pandas, ClickView. There are a lot of different analysis tools. That's a more separated thing. You don't get the coupling problems I showed you. You have the possibility to have different schemas than in your online database. Example, in your online database, you just have numbers of regions, and you have a lookup table which connects 1 with Tuscany, 2 with Rome, and 3 with another Piedmont. That's the 3 regions I got from Italy. You have 1, 2, 3 stored in your database, and you always do the lookup. You can transform it to your analytic database and put in the region names. So faster thing, you can do pre-processing, like if you only ask for daily revenues, you don't need the data on a second or minute basis, you can summarize on days. The challenge is the data will be not as actual as if you are accessing the live database. And on that extract, it's usually a select everything from big table. You have a full table read, which will usually influence the caching of your online transaction processing system. If you go for an analytic databases, why not use PostgreSQL? Anyway, if you have 200 billion records and you want to sum them up, you can't win anything by using clever indexing. If you want to sum 200 billion records, you have to read 200 billion records. No way around it. So in 9.5, there are some extensions for parallel aggregates for sum and average available. the parallel read and some parallel things are scheduled to be in 9.6 so that multiple cores can do the reading. Anyway, with one PostgreSQL instance, you only have the storage bandwidth of one storage. So that's just a limitation. How fast can you read? If you want to get faster, if you want to read more bytes, the only way is to have multiple storage and to have an analytic database which combines this. Simon presented this morning the PostgreSQL XL analytic database, which exactly does that. Just before you go there, I just did a research what's currently available at processing speed or bandwidth speed of data storage. And I got the PCIe SSDs, which are available from your favorite online retailer at 2.5 gigabytes a second. That's the usual stuff you can get. And there are single vendors who claim they have 5 gigabytes per second read speed. We all know that storage vendors lie as much as politicians, but still, we have some area of speed, what's available, and we are talking in the 1,000 euros per terabyte range. Of course, there are server-grade things where you pay 10 times this just to have a specific label on it, but that's the dimension we are talking, what's available right now for single storage bandwidth. So before you think about having multiple processing cores, just do a, we call it napkin calculation. How much data is there? How many bytes do I have to read? Do I really have to read my YouTube videos I stored in the byte fields of the database? If you go for PostgreSQL XL, good thing is it's based on PostgreSQL, it's closely following it. You can use the same SQL, and now you have the possibility to use multiple nodes to do your work. So you can not only use multiple processor cores, but you can use multiple storage cores. On a sad thing, I see Johnny is looking sad because you have to buy multiple storage to do it. So yeah, it's not free. The coordinator will put the results together. So the price you pay, you have to distribute your workload on multiple machines. That costs something in complexity and in time and in latency. You have the time to distribute the workload to the nodes and the time of getting it together. You have the bandwidth of the network and latency, because what you can get from storage at bandwidth and what you can get from network as bandwidth, the PCIe attached storage will be on orders of magnitudes faster than what you can get on network things. Maybe that changes. On the pro side, you have the bandwidth of the multiple storage, you have the calculating power of multiple cores, and you have the cache of multiple main storages that can be used for that thing. Now, back to our towel sales company. They want to have a website. Even in a towel business, we are going online now. They are just very simple. They just want to push information. We want to show them what we want. They shall not touch our information. Our operation shall not suffer. It's not a cool Web 2. Whatever company. It's a very basic ground-standing business. So they want to publish information on the web. The first level, they can just extract the data from their database and transfer the files, the copy or the dump files, to the web server, load it and present it there. Sounds funny after all those triggers and geological and streaming and whatever. Just, the good thing is you have zero coupling. So what's happening on the web server and in your machine is not coupled at all. You have a challenge with the actuality because as often as you do that extract and push it out, that's the thing that's on-site. But who hasn't got a mail from some major deployer? Those informations may be on our website this evening, or we don't have online information. It may take up to 12 hours for our website to update. Insurance, banking industry, they still take 1 day to send money from one thing to the next day, because still we can do it in nanoseconds, that processing, but yeah. So for something, it's good enough. We still have to load on extract. Now, if we want to connect it tighter, we can use the same things we use for our backup server. That we can use trigger streaming based or the new kid in town geological. And I put in, instead of repeating the features, I put in a table to get an overview. What should you use when? The trigger-based replication, the good thing is you can go down to a table granularity. Always remember, we are talking relational databases, so transferring a single table is only sensible if this single table does not have relational dependencies to other tables, else it's useless. So it's just the possible granularity. You can do a table. On streaming replication, you can only get the whole PostgreSQL cluster. So if you have on one PostgreSQL cluster the secret password database, your sales database, and your marketing database, if you do streaming replication to the web, all three databases will be on that separate server that's published to the web. geological also has a table granularity. The write load on the master server, if you use trigger-based, you have roughly double write load. It's complicated to calculate exactly, it's double. If you use streaming replication, it's a little bit more because there are some extra bytes. And if you use logical, there are even some bytes more. But we are talking in a single-digit % range of more bytes written. The processing load is essential. The trigger has to be fired. The system has to wait until the trigger has finished and to give it back. There is some complexity in the trigger. The guys at Skype with Londista and Sloaney are really brilliant. So it's really, really great code, but even great code needs to run, needs to fire, needs to write, needs to return. The processing load on streaming and geological is essentially zero. Essentially because streaming replication needs additional information written to the wall files. That additional information is usually present. geological also needs more information written to the byte stream, and to get that information takes some cycles, so you can configure it. That white thing is schema changes or data manipulation language. With trigger-based replication solutions currently available, it's just painful. With streaming, it's fine, you don't feel it. And with geological, it's possible, but a challenge. You see the difference between pain and challenge. Reason is, we had many years more experience and we have a more advanced PostgreSQL. Now we have event triggers that fire if somebody does a DDL language on the master server, an event trigger fires, so you can capture those things. We have a lot more tools on the database level to stream those data definition language, but as Peter described in his talk, it's not streamed by default, it's not replicated by default, so it's still challenging, and it's also challenging to get it right from a logical level, because you have to have the additional column before you start replicating data that consists of that additional column. So it's a challenge still. The age of the system, the trigger-based are the oldest one. The streaming one is a grown-up, mature, and geological is new. It's fully supported. We have the bidirectional replication out there in more than 10 installations, fully supported productive, but it's new. Good thing about between versions, you can do it with trigger, you can do it with geological as long as the version is newer than 9.4. You can't do it with streaming replication. Different versions is translated to different major versions. Between operating systems, like your company is using Windows inside and Linux outside, it's possible with the trigger-based things. It's impossible with streaming-based, and it's theoretically possible with geological. Theoretically, because nobody came around in getting a Windows version for geological deliverable. So it's theoretically possible from principle, but not available. From other databases, you can do it with only with trigger databases, like we promised or demonstrated with Oracle. The nice thing, two other systems, You can do it with Triggerbased, and you can do it with a logical replication. And that's what this morning Valentin was speaking about, where he takes the logical decoded data chain stream from PostgreSQL and pushes it in some Japanese manga event management system. Something about the next generation, an overview of PG Logical. I was talking about there have to be some additional bytes to the reward stream. That's the setting in your configuration files. Just what is that WAL file where I showed you the development in Genua in 1314? The usual WAL files contain binary change nodes to the tables. That is, if you look in your PG data, base 1 or something are the directories, you see those file names. That is the table ID or the OID of the table. So the files are really called 1804, 1801, whatever. And the WAL file contains change nodes as in go to file 1804, go to position, whatever, and write the following bytes, binary change nodes. Logical decoding adds some more information, and logical decoding will take those binary change information and re-engineer logical change information. Very important, it does not reconstruct the original query or DML thing, it reconstructs logical change sets. So in file 1804, write on position to the bytes thing, PG Logical will decode it to something like in table towels at record mid primary key 758, write the following fields. So the good thing is the statements that are produced by logical decoding by PG Logical are something like the food astronauts eat. It's pre-digested for the applyment. And so no repassing is required on the slave of the PG Logical. Different PostgreSQL versions are enabled as long as they are higher than 9.4. I already gave that different operating system is possible, and the challenging things for DDL, change of schema are still challenging. Once again, the query duplication, that's a very, very important thing, especially for that what will come with the Multimaster thing. Volatile functions are frozen on their result. So if you have something like insert into dices values random on your master server, it's not that query that it's given to the slave, but on the master it will execute, random will return 5. I know that random is returning a floating point, but just for the understanding. So random will return a 5. So that insert will be insert into dices, set i's to 5. And that will be replicated to the slave. I'm using random, not that it's a very useful thing in a daily thing, but it's a very useful thing for a pedagogical tool to really understand what's happening. The other thing is, if you do a mass update, like update towel set price equals price multiplied with 1.05, that's in bookkeeping language, add 5% to the price. What is happening? PostgreSQL will select all the records in the towels table and do an update on them. So what's written to the changelog is write number of records in towels with the new price information and write to the number of, to every record, it's invalid. So you have change sets, the number of change sets that are written are equal to the number of records in a towels database. That's something to know. It already happened with streaming replication, you have to transfer it. It also happens with logical replication. No problem if your server is standing with a gigabit link in the next door. It may be challenging if your server is standing somewhere in the African bush connected with a satellite link and Windows is pulling updates at the same time. Just to be aware of it, what's happening and what to avoid. Now, we are going to the final stage We open a sales office in Mallorca, and you know we need a lot of towels in holiday areas because we Germans need to reserve our sunbeds in the morning. So they have a local storage for those towels to deliver them to the hotels. They take care of the hotels on the islands, primarily with towels they have already on board because they are fast. The whole company, the Towel Sales Europe, needs consolidated reports about what is happening in Mallorca and in Hamburg and the other affiliations I'm not mentioning. And they also have people to do the master data of the articles, like putting in pictures of them, setting the price, doing the marketing. Everything is happening in Hamburg. There's just a sales office who does the local business. That's the correct thing for BDR, PostgreSQL bidirectional replication, which is available as a Spoon to 9.4. It's production ready. It's Spoon is something like a fork, but it's closer. And it's in production, it's supported, it's at least 9 or 10, I don't keep up, production installation of BDR we know of and we support currently. It's a multi-master replication thing, and our fantasy, which I built up, is perfect for it. The customers in Germany are taken care of the German branch. The customers in Mallorca are taken care of the Mallorca branch. So we don't have a lot of overlapping rights because every sales guy will shoot you in the head if you sell into his area of expertise. So generally separated data, but consolidated reports, hot. That BDR is based on logical decoding. It does the same thing I explained to you with the logical decoding and change sets and applying. The same caveats apply. We have additionally the handling of conflicts and global sequences. Essentially, that gives BDR. There is no free lunch. To get one application that is single master and slave or read something to a multi-master application is major work. Usually we have an assessment and helping the customer, and we do it at principal level, and it takes usually 5 days just to get the knowledge how to adjust an existing application to multi-master workage. So don't expect something like, hey, I've listened to half an hour Harald talking, now I know everything to do my multi-master application. I just give you some food for thoughts, what you have to think about. There is something I called you're holding it wrong. The only thing I really admire of Steve Jobs. There are quite some things you should avoid when running in a multi-master environment. The same thing as with geological, with the mask changes you shouldn't do. And then we have what may be a two-phase commit or something. If I don't go into the technical discussion of computer science, just from the principle. If you do something that involves data on both servers, avoid doing it. If you can't avoid touching in one transaction data on both masters or multiple masters, do it as quick as possible. So something like reserve towels and wait for the customer to decide how many sunbeds may I reserve, and then do it on the next one, and then maybe roll back or don't roll back. That's really challenging in a multi-master thing to get it right and to understand what's happening. One thing, 2 updates may rather hit the same primary key than 2 inserts. I'm not sure if it's not possible to hit the same primary key with 2 inserts. It should be theoretically impossible, but I haven't tested it yet. So updates in a multi-master system are much more likely to cause conflicts than inserts. So if you can formulate your application logic by inserts, you will run in less conflicts than you are doing updates. Just a simple example to finish up this talk, because Britt is already nervous for the final session. That's totally right. Very good. No, we're just finishing up. You're keeping stock. you can do when you sell your towel, you can say update stock, set available towels, recent towels minus sold towels. Or you can keep a list of towels sold, and if you want to know the available numbers, you take just the sum of all those things. You pay another price for it because you have to run through it. You can optimize that. You can think of going for guesstimates or something. Just think which prices do you pay to have a multi-master thing and be prepared to pay them. I've come up with a picture I really like. If you go into a bar and there is a place which has an unused set of tables and, is it tables? No, dishes and spoon and knife and fork and glass, and you sit down at that place, it's much more likely that there won't be a conflict with the guy of the used set who just went to the toilet and comes back. So imagine the same thing with Multimaster. The more you can avoid of those conflicts, the less challenges you have. There is something in BDR to deal with those conflicts, but better avoid them. So that much as food for thoughts for bidirectional replication, and that also concludes the overview of why you should or could have data on multiple systems and what to do or what not to do. Thank you very much.